The point P, negative 4 comma 3, is a terminal point of an angle theta in standard position. To the nearest tenth of a radian, determine possible values of theta between negative 2 pi and 2 pi. What kind of question do you think this is? It's a triangle question. Do you recognize the wording is similar to the one we did earlier in degrees? They tell you a point on a terminal arm. As soon as you know a point on a terminal arm, you can draw a diagram for that. Negative 4, comma 3 is right there. That's on the terminal arm of an angle in standard position. So then you can draw your right angle triangle. Here is your reference angle. You know that this length is 4. Oh, excuse me, I am got a cold. Boy. All right, get the weekend to recuperate. So we know that that side's 3 and that side's 4. And we want to find the possible angles of theta between negative 2 pi and 2 pi. Can you see that that's once around the circle from 0 to 2 pi in the positive direction, and once around the circle from 0 to negative 2 pi in the negative direction? We're going to get two answers. One of them is going to be this angle theta. That's in the positive way around. And one of them is going to be this angle theta, the negative time around. Either way, we need to figure out what our reference angle is. And we do everything the same as degrees, except we deal in radians. And the biggest difference is you get answers you're not used to. But the process is exactly the same. So if we were figuring this out in degrees, what would we do first? You'd find your reference angle. Well, your reference angle is part of this triangle. SOHCAHTOA, since it's a right angle triangle, you see you have your opposite side. You see you have your adjacent side. And so I would probably use tan. Tan of my reference angle is 3 over 4. And when you're dealing with your reference angle, think of it as an actual triangle with all positive values. We're not worried that the 4 is negative because it's going to the left. We're not worried about the 3 being positive because it's going up. We just think of it as a regular triangle. This length is 3, that length is 4. And when finding reference angles, you always deal with only positive values because your reference angle is always going to be a positive answer between 0 and 90 degrees when you're thinking in degrees. But when you're thinking in radians, so when I go tan inverse of 3 divided by 4, I get 0.643. Does it need to be rounded? 0.644. Approximation signs there. You are not going to recognize that as well as being between 0 and 90 degrees. Is that between 0 and pi over 2 radians? It is. What is pi over 2 as a decimal? .14 divided by 2, about 1.57. Yeah? So this number is between 0 and 1.57. So we have a correct reference angle. But I'm going to tell you, your brain doesn't immediately go, yeah, that works. That's between 0 and 90 as fast as it does with degrees. So that's going to take some time. We have our reference angle, and as long as you've done all positive values, it will be right. Now that we have our reference angle, how would you figure out what theta is? Well, we do it the same as degrees. Let's say I have this angle right here. It's about 32 degrees, 33 degrees, 35 degrees, I don't know, something close in there. If I have that angle as 35 degrees, how would you figure out the green one using degrees? Just subtract it from 180. So it's not, you know how to do it. Now we have to think in radians. Instead of subtracting our angle from 180, we have to subtract it from pi. So we go to our calculator, and I'm going to need that reference angle often. So something that's useful on your calculator is the store button. Right above the on button is the store button. I often just store things as x because it's the easiest button, easiest letter to find. So if I store that as x, your calculator remembers every time you hit x, it will type that number. So if I want to do pi minus my reference angle, I could go second answer here, but now that it's stored, I could just go pi minus x. And we're told that that green angle is 2.498. To the nearest tenth would be approximately 2.5. And if you were dealing in degrees, and this was 35 degrees, how would you figure out your red angle? Again, I would think positively. I would go, well, this is 180 degrees plus my reference angle. And then whatever answer I get, it's going to be that negative answer. So 180 plus 35 would be 215. Then I would know that that red angle is negative 215. Now we do that same process in radians. Halfway around is going to be pi plus your reference angle. So if I go to my calculator and go pi plus x, 3.8, I would know that that negative angle is negative 3.8. And now we've found all the answers between negative 2 pi and 2 pi. Part B. Again, we've done these questions in degrees already. The only thing we're changing, I can go back. It's good? Okay. The only thing we're changing here is we're doing this in radians. So first of all, we have cotangent of theta equals negative 2. That's not going to be very helpful for us because we're not used to that. So the first thing I would do is change it to tan. If cotangent of theta is negative 2, then tangent of theta is negative 1 over 2 or 1 over negative 2. With that, you can now draw your triangle. Where am I going to draw my triangle? In the second quadrant? Opposite over adjacent. Good. Is that the only place you could draw your triangle? You could also draw it in the fourth one. Yes. Because according to the cast rule, tan is positive in 1 and 3, so it's going to be negative in 2 and 4. Label your reference angles. So you create the exact same triangle in both ones. Now it doesn't matter which of those triangles you use, you can now figure out your reference angle. And I like you to write it out with that. Tan of our reference angle is 1 over 2. Notice tan was negative 1 over 2. But with your reference angle, you're thinking of an actual triangle. You use positive values all the way through. Go to your calculator. Again, our calculator is still in radians. Second, tan inverse 1 divided by 2. And our reference angle is 0.464. Again, practice those approximation signs. You will notice that you will probably do that as well. You never think about your approximation signs until after you write your equal signs. And then you have to like draw over top of them. They get really messy. There's our reference angle. So now that we have our reference angle, we want to find all of our answers of theta between 0, negative 2 pi, and 2 pi. Again, I like to break it up into positive answers and negative answers. Positive answers, can you see that you would go from 0 to 2 pi? So there would be one positive answer here and one positive answer here. For our negative answers, we'd have to go from 0 to negative 2 pi. So we would have one negative answer here and our other negative answer there. We'll do our positive answers first, our green ones. In quadrant 2, if that was degrees, can you see that you would do 180 degrees minus your reference angle? Since it's in radians, we're going to do pi minus our reference angle. I'm going to go back to my calculator. I've got a new reference angle. I'm going to store it as x. So your calculator just keeps storing things over top of x. And it doesn't affect graphing, and you don't have to clear it. You can just leave it as it is. In fact, before you stored your first one as x, x was probably stored at 10 if you've never used the store button. Or if you've used it before, it was whatever you did last. So now I've got my reference angle. I'm going to go pi minus that reference angle. Did it say to the nearest tenth or something? Nearest tenth? Oh, approximately. That first one is 2.7. The second positive angle, if that was degrees, you would go 360 minus your reference angle. Since it's in radians, you will go 2 pi minus your reference angle, 5.8. And now for our negative angles. The one in quadrant 4, can you see that that's exactly the same as your reference angle? Just negative? So our reference angle was 0.46. To the nearest tenth will be negative 0.05. I just figured out this one right here. Our reference angle has been the same for all of them. It's 0.464. I took this one, negative 0.464. This is the same, just rounded to the nearest tenth. Okay? Just looks so different. I know it's kind of scary. It's like, oh, where did a half come from? Half is such a nice number. It's rounded. It's not a nice half. There's a nice half. Those aren't rounded. This is a rounded half. It's like a little sketchy. Okay. Everybody good now? And then for this one, if it was degrees, you'd go 180 plus your reference angle. Since it's in radians, you're going to go pi plus your reference angle. .6, and that will be negative. And so we've got all of our answers between negative 2 pi and 2 pi, and we're just dealing in radians instead of degrees. So one of the things you really have to feel confident in is how to do this in degrees, because now you have to switch over to numbers you're not used to, numbers that don't tell you if they're way off. Right? If you were solving this in degrees and you got 8 billion degrees, you'd be like, I think something's wrong. Now you're like, yeah, whatever, maybe. And then you just keep going. These are really important questions. Make sure you try 13 and 14.